Okay, geometry students, in this video we will be studying the lengths of the sides of triangles in relationship to their angles, and we'll also be studying the converse of this, okay? Now after we're done studying that, we will also be studying situations in which triangles cannot exist, okay? So that's what we're going to look at today. Let's go ahead and copy your heading down for today. Your heading is called Triangle Inequalities. Triangle inequalities, and the lesson number is 4.7. Okay, lesson 4.7. I'll pause a minute while you copy this down. Your heading today is called Triangle Inequalities, lesson 4.7, and be sure and include today's date. Okay, let's continue on. Now, in this lesson, we are supposed to learn 3 theorems, okay? Which is a good amount of memorization for you. However, instead of giving these to you in theorem form, I am just going to give them to you as mathematical rules. And this will make it easier for you, okay? And I feel like they're easier to understand. I do this occasionally when I feel like the theorems or the principles that I want you to learn are easier to understand when they're not written in theorem form, okay? And so in this case here, it's actually easier to understand the math that I want you to learn than it is the wording of the theorem. So I'm not going to worry about making you memorize these, okay? With that in mind, here's the first thought. Students, please write this down, okay? Here we go. And you can see now how confusing this sounds, okay? The largest, so you do not need to memorize this, but please write it down. The largest angle is always across from the longest side. The second largest angle is always across from the second longest side. And the smallest angle is always across from the shortest side. Now I should have put this in here. This is true when we're dealing with what? Triangles. I'm going to pause a second while you write this down. The largest angle is always across from the longest side. The second largest angle is always across from the second longest side. And the smallest angle is always across from the shortest side. While you're copying this down, also write down this next really short sentence. The converse of this is also true. So please write down these two statements. The largest angle is always across from the longest side. The second largest angle is always across from the second longest side. And the smallest angle is always across from the shortest side. And the converse of this is also true. Let me give you a picture of what they're saying, students. I would encourage you to write this down, okay? I'm going to draw a triangle here, like this. I'm going to quickly just list out this. I'm just going to make up numbers for the sides here. We'll say 5, 8, 7, okay? Now notice that you have no idea what these angles are, okay? You have no idea what the measurement of this angle is, or what the measurement of this angle is, or what the measurement of this angle is, okay? But did you know you can still list out the angles? You can still tell me the smallest and the largest and the second largest angle. Look, watch this carefully. Here's what this statement is saying. Find the longest side. Here it is. Now go straight across the opposite angle. This is the biggest angle. I know that's the largest or biggest angle because it's directly across from the longest side. Isn't that easy? That's all this statement is saying. Look at this. What is the next longest side? 7. So I know that this angle here is the second largest angle because it's across from the second longest side. Now, I know where the smallest angle is because here's the smallest side. Go straight across, and that's the smallest angle. It's that easy. So even though sometimes you don't know the measurements of the angles, we still know some things about them, okay? Now, notice this statement here. The converse of this statement up here is also true. Let me show you what that means, okay? Let's pretend that I put the angles in here. 100 degrees, 50 degrees, 30 degrees, okay? Now, I can tell you what the longest side is. Even though I don't know the lengths of any of the sides, go to the biggest angle, well, 50, 30, 100. Now go straight across. This is your longest side because it's across from the biggest angle. Now look at the second biggest angle. Go straight across. And this is the second longest side. Now find the smallest angle. Go straight across. And this is the smallest, or the shortest side, if you will. Okay? And that's really simple, and that's all that these two statements here are saying. This one here and this one here. Okay? Now with that in mind, let's work some problems and apply these two truths. Okay? Here we go. I want you to take this, copy it in your notes, please. Everyone take notes on this. Please copy this in your notes, this triangle. Draw this quickly the best that you can. And I want to know what the largest angle is and the smallest angle. You can work ahead or you can watch me, whatever you want to do. Okay? I want to know what the largest angle is and the smallest angle. Well, now the largest angle is going to be across from the longest side. So I'm going to find the longest side. Here it is. Go straight across. And there we go. Angle N is the largest angle. Piece of cake, guys. Now, I'm going to find the smallest angle. So I find the smallest side up here, which is 12. Go straight across to the angle opposite that side. And there's the smallest angle. Right? Pretty simple. Let that sink in. We're going to move on in just a second. Okay, here we go. Now go ahead and copy this in your notes, please. Go ahead and copy this in your notes. And you're welcome to work ahead, or you can just stay with me, whatever you would like to do. In this problem here, I want us to list out the angles from smallest to largest. List out the angles from smallest to largest, okay? So here we go. I'm going to find the smallest side, which is this side right here, and then go straight across. So angle P is the smallest angle. Now I'm going to find the next smallest side, which would be 20. Go straight across to this angle, and that would be the second smallest angle. And now I'm going to find the longest side, and that's across from the largest angle. So angle Q would be the largest angle. So there we go. I listed my angles out from smallest to largest. Okay? Really not that difficult, guys. Pretty simple. Okay? Alright. You're on your own on this one. I want you to copy this down, pause the video, quickly do this. Shouldn't take you more than probably 60 seconds. And I want you to list out the angles in this problem from largest to smallest, okay? So go ahead and do that now at this time. Okay, students, hopefully everyone is finished now. Let's go ahead and look at your answers. The largest angle would be angle U, okay? Angle U. The second largest angle would be angle S, okay? Angle S. And then the third, well, the smallest angle would be angle T. All right, angle T. Now these are pretty simple problems. I don't think you guys will struggle with this math today. However, I just want to make sure that we're getting it, okay? So let's quickly do the opposite now, or the converse. I want to give you 3 of these problems. So quickly go ahead and copy this in your notes, please, if you would. Copy this triangle in your notes. And when you're done copying that triangle, I want you to tell me what the longest side is and the shortest side. Okay, so I'll pause a second here while you do that. Copy this triangle down and then tell me the longest side and the shortest side. Okay, here we go. Now, if I want to find the longest side, I'm first of all going to find the largest angle, okay? So here's the largest angle right here. I go straight across, and this is my longest side right here, AC. Okay, so my longest side would be segment or side AC. Now my shortest side will be across from the smallest angle. So I'm going to find the smallest angle up here. Here it is, 35. Go straight across. And this side here will be my shortest side. Okay, AB. So segment AB. There we go. Now on this next problem, go ahead and copy this triangle in your notes, please, students. On this next problem here, I want us to list out the segments or the sides of the triangles from longest to smallest, or longest to shortest, okay? So we're going to list out the sides of this triangle from longest to shortest. I'll give you guys just a second to copy this triangle down and we'll get started. Please copy this in your notes. And here we go. Okay, we're gonna list the sides out from longest to shortest. So we're gonna start off with the longest side first. So we're gonna find the biggest angle. There it is. Go straight across. So the longest side would be EF. Next, we're gonna look for the next biggest angle, which would be 54. Go straight across, and that would be side DE. Okay? Side DE. And then lastly, we're going to find the smallest angle, which is 48. Go straight across, and this will be the smallest or the shortest side of the triangle, side DF. There we go. Pretty simple, guys. Okay, I'll give you a second to quickly finish up here, and we're going to move on. This is a pretty nice way to finish up a chapter, guys. I mean, this is pretty simple stuff, so. Okay, here we go. Moving on to this problem here. Go ahead and copy this in your notes, and you guys are on your own on this problem, okay? I want you to pause the video, and I want everyone to list out the sides from smallest to, or I guess the best way to say it is the shortest side. I want you to list out the sides from shortest to longest. Okay, so go ahead and pause the video. Everybody copy down this triangle, and then you guys are totally on your own. I want you to list out the sides from shortest to longest. Okay, hopefully everyone's done. Let's go ahead and take a look at this. Okay, let's start with the shortest side. The shortest side will always be across from the smallest angle. So let's find the smallest angle here, 38 degrees, and then go straight across. Here's HI. That'll be your shortest side. Okay. Now, let's find the next biggest angle, 39. Go straight across, and that would be side GH. And then lastly, we're going to find the largest angle up here, 103. Go straight across. And this side here will be the longest side. I hope you guys are getting this okay. It's not too difficult. And I hope I've not made any little mistakes along the way that I've not seen. But there we go. We listed out the sides or the segments from smallest to largest, okay? All right, let's continue on. Let's move on now to our last topic of the day. One more topic and we're finished, okay? Here it is. The sum, that means when you add, the sum of any two sides of a triangle will always be longer than the third side. Write that down, please. The sum of any two sides of a triangle will always be longer than the third side. Always. So please copy that down. The sum of any two sides of a triangle will always be longer than the third side. Now, it always helps to get a picture, so let me give you a picture of what I'm saying, okay? You're welcome to copy this down. You don't have to if you don't want to. It's up to you, but here it is. Okay, now notice this. Notice 3 plus 5 equals 8. Okay? And notice how 8 is less than 9. It's not as big as the third side. Well, here's why it's impossible to have a triangle that has two sides that when you add them together, they're less than the third side. Look at this picture. It shows you why it's impossible, and it shows you why this is true up here. Okay, now watch this carefully. Look. No matter where I move these sides here, like this, or the other direction, no matter where I move this side here, this way or this way, these two sides will never touch, even if I go all the way down with them to here and take this side and go all the way down to here. They're still not going to touch, guys, because this is how long here? 3. This is how long here? 5. And 3 plus 5 is 8. And this whole segment here is 9. Okay? Now, if you don't understand this example I just gave you, that's okay. I'm not going to test you on this and make you explain to me why this is true up here, but I just wanted to show you why this statement is true up here, okay? If you take any two sides, if there's just one situation, like you said, well, Mr. Earhart, 3 plus 9 is 12, and 12 is greater than 5, true. 5 plus 9 is 14, and 14 is bigger than 3, true. But if this fails in just one situation, then the triangle cannot exist. So the best way to check these, now listen to me, the best way to check a triangle when I give you segments is to add, I want to write this down, the two smaller sides. Always add the two smaller sides and compare it to the third side. If you'll do that, that's all you'll have to do. Because think about it, students, if the two smaller sides, when added together, are bigger than the third side, then all the other sides, when added together, will be bigger than the other leftover side. It works every time. It has to be that way, okay? So, having said that, here's what I want us to do. I want you to tell me, yes, it is possible to have triangles with these lengths, or no. Okay? And the easiest way to do this, instead of testing all kinds of different scenarios, the best way to do this is like this. So take some really good notes. Okay, let's copy these problems down. I'll pause a second while you do that. And then let me show you how to answer these questions. All right, here we go. Now, find the two smallest sides. Here they are. Add them together. That's easy. Okay? And then state that once you've added them together, they must be greater than, the leftover side. Now what's the leftover side, or the longest side? 3. So let's see if this is true or false. 1 plus 2 is 3. 3 is greater than 3. No, that's not true. So no, it is not possible to have a triangle with these measurements here. Now, are you saying, Mr. Earhart, that the triangle will never have measurements of 1, 2, and 3? That's correct. There is no triangle that exists that can have measurements of 1, 2, and 3. Okay, let's try another problem. Pretty simple stuff here. Pretty cool stuff. All right, let's move on to the next problem. Find the two smallest or shortest sides. Here they are. Okay, let's add them together. And then say they have to be greater than the third side, which is 15. Let's see if that's true or false. 6 plus 10 is 16. Is that true or false? Is 16 greater than 15? Yes, that's true. Check. It works. So is it possible to have a triangle that has 3 lengths of 6, 10, and 15? Yes, it is. It is possible, definitely. So this triangle here does exist. All right, let's continue on. All right, let's try this problem here. You can work ahead on these or stay with me. It's up to you. All right, let's circle the two smallest sides, or the two shortest sides, 12 and 16. So we have 12 plus 16 is greater than 30. There we go. Add these two together, and we get 28 is greater than 30. Now, is that true or false? It's not true. So is it possible to have a triangle ever that has the lengths of 12, 30, and 16? No, it is not. No triangle will ever exist that has these 3 measurements for its 3 sides. It is not possible. Okay? All right, let's continue on to our last one, and then we're finally finished. Okay, let's circle the 2 shortest sides. Here they are, 7 and 8. So 7 plus 8 is greater than the third side, which is 13. And let's see if that's true or false. 15 is greater than 13. Well, that's true. So check, is it worked? So is it possible to have a triangle that has lengths of 7, 8, and 13? Yes, most definitely. Okay, definitely. And that's it, guys. Let's quickly review for like 10 seconds, and then we'll be done, okay? Okay, you need to understand this. The longest angle, the largest angle is always across from the longest side. The second largest angle is always across from the second longest side. And the smallest angle is always across from the shortest side. Also understand that the converse of this is also true. And then you should be able to list out angles, smallest to largest, and so on and so forth. And sides also. And then lastly, understand that the sum of any 2 sides of a triangle will always be longer than the third side if you truly have a triangle, okay? And you should be able to look at sides like this and tell me, is it possible for these triangles to exist, or is it not possible? Okay, that's it for today. If you have any questions, don't hesitate to call or email.